Today we're going to solve rational inequalities. Those are things that look like these three examples here. So these are your steps. Get it equal to 0, then add the two fractions together. You're going to have to find a common denominator. Set the top and the bottom equal to 0 and solve. Remember, that means sometimes that we have to isolate the x, or if it's an x squared, you have to factor. Then we'll plot all of our numbers on the number line. The bottom will always be an open circle, but the top depends on what the inequality sign is. Test each interval to figure out where to shade, and then write your shaded intervals in interval notation. So let's start. I have a couple of examples for us to go through. Here's our first one. Solve 9 over x minus 2 is less than or equal to 3. So step number 1, we want to get it equal to 0. So subtract your 3 over to the other side. All right, step number 2, we want to add these together. I need to get a common denominator so I can write them as one fraction. So right now, if you want to write this 3 over 1 to make it clear what the fraction is, common denominator means they have to have the same denominator. This first one has an x minus 2, so I need to put an x minus 2 here with the second one. Whatever you put in the bottom, you need to also put in the top, so that way you could cancel them back out and get the original problem. All right, now that they have a common denominator, I can just subtract across the top 9 minus 3 parentheses x minus 2 and write your common denominator in the bottom. And we do not necessarily have to go on and distribute the top, but we're going to have to, I guess, when we're solving. So we might as well go on and distribute our negative 3 and combine like terms. Okay, so step number 1, get it equal to 0, which is what we did. Now I can add the two together, get a common denominator, and distribute and combine like terms. We're going to set the top equal to 0 and set the bottom equal to 0 and solve. So kind of off to the side, you're thinking, okay, negative 3x plus 15 equals 0. There's not an x squared or anything here, so just isolate your x. So subtract your 15. So my first answer is x equals 5. Do the same thing. So that was setting my top equal to 0. Now I'm going to set my bottom equal to 0 and solve for x. I just have to add 2 over to the other side. All right, plot these two numbers on a number line. Make sure you put them in the right order from negative numbers to positive numbers. Anything in the bottom, the denominator is always an open circle. That's going to be hard to remember, but it's always an open circle because you never divide by 0. And if this was a closed-in dot 2, we'd be subbing in a 2 into this equation and divide by 0, which isn't acceptable. So bottom is always an open circle. The top one depends on what our sign is from the problem. And since the problem is less than or equal to, that means we're going to use a closed-in dot for it. Test each interval to figure out what parts to shade, just like we've done in the past. So I'm going to pick a 0 because 0 is an easy number for me to sub in. And 0 on a number line would fall right here. So I'm going to go up here. You can go look at the original equation, or you can just look at this one and sub in a 0. So if I subbed in a 0, okay, simplify across the top, I'd get a 15. Simplify across the bottom, I'd get negative 2. And then look at your overall fraction. This is going to be negative 7.5. Is that less than or equal to 0? Yes, that means shaded in. Technically, you have to check every single interval, but your homework is set up that every other interval is the ones that work for you. So if you wanted to test this interval, you could sub in a 3 or a 4 and see it's going to give you a positive number. If you wanted to test this interval, you could sub in a 6 or a 7 or an 8, and it's going to end up giving you a negative number that is less than or equal to 0. Or just shortcut it and know that our homework's always set up that we shade in every other number, every other interval. And then this one, unlike the last times when we've done these inequalities where we've stopped at shading, this time we have to give our answer in interval notation. I'm not sure why it's giving us that extra step, but remember, for interval notation, use brackets for your closed-in dots and use parentheses for everything else. So what part is shaded in? Number lines go from negative infinity to positive infinity. So from negative infinity to 2, and from 5 to infinity is shaded in. Done. All right, that's our first example. So we got it equal to 0. We found a common denominator. We distributed it in combined like terms. Then you solve the top, solve the bottom, plot them, check an interval, and write your answer in interval notation. Let's do a couple more. Okay, let's solve this one. 1 over x plus 1 is greater than 2 over x minus 1. All right, I'm going to have to subtract this over to the other side because I need to get this equal to 0. All right, now that I have it equal to 0, get a common denominator because we want to add these together. This first one has an x plus 1, so that means I need an x plus 1 in the second one. Whatever you put in the bottom, put in the top. The second one has an x minus 1, so I need to put an x minus 1 in the first one. Whatever you put in the bottom, put in the top. Add across the top, or in this case, I'm going to subtract. So x minus 1 minus 2 parentheses x plus 1, and then write your common denominator in the bottom. I don't have to have my parentheses here anymore just because I'm distributing a 1, and 1 doesn't really change anything. 1 times x and 1 times negative 1 is still x minus 1. But I do need these parentheses on top because I am going to want to distribute my negative 2 and combine like terms. You don't have to distribute out the bottom because one way for us to solve this, if we distribute it out, it's going to end up being something squared. And the way we solve squared things is factoring it. So we just undo what we just distributed. So once you have the top all multiplied out and distributed, step number 3, set the top equal to 0 and solve, and set the bottom equal to 0 and solve. For the bottom, since it's factored, set each factor equal to 0 and solve. Plot on a number line. Make sure you put your numbers in order from negative numbers to positive numbers. The bottom is always open circle. The top depends on what this symbol is here. And since it's a greater than, not a greater than, or equal to, it's going to be an open circle. All right, let's see what we're going to shade in. I'm going to choose 0 because that's an easy number for me to sub in, but you can pick whatever number you want to. 0 would fall in right here between negative 1 and 1 on a number line. So I'm going to sub in a 0. Simplify across the top. Simplify across the bottom. And then look at your overall fraction. 3, is 3 greater than 0? Yes, so I'm going to shade in that interval. And the way your homework's set up, you shade in every other interval. That's not always true if you take other math classes. All right, your final answer should be interval notation. So what intervals are shaded? This one from negative infinity to negative 3, and this one from negative 1 to 1. The only time we use a bracket is if we have a closed-in dot.